All right, number 6. So we're given a quadratic looking curve, well, quadratic maybe, and it intersects at 2.06. Okay, it says the curve C passes through the origin and passes through 6, 0. The curve C has a minimum point 3 minus 1, so that's right at the bottom here. Now on separate diagrams, it wants us to sketch these two types of curves. Now let's look at part A for a second, y equals f2x. Now one thing to memorize is that when you're working inside the function where the x is, you're dealing with x coordinates. Another thing to note is that it works in reverse. So if it says 2x, you're actually halving the x coordinates. So copying out every single coordinates on this equation, we can say that 6, 0, halving the x will make it 3, 0. And as for the second one, 3 minus 1, halving the x coordinate will make it 1.5 minus 1. And you can kind of see that if you had to copy the sketch, this 6 has moved inwards halfway across the 3. So it's about here. And 3 has moved halfway to 1.5. So it's there. And of course, the origin 0, 0, when you halve the x is still 0, 0. So that doesn't change. So it's going to be the same shape like this, still cutting through the origin. Okay, part B now. So we've got a sketch y equals fx plus p. Okay. Now for this one, it gives you a constraint for p. It says that p is between 0 and 3. Another thing you need to note for these type of equations is that this is known as a translation. If you got x plus or minus, it means you're working with the x and then you're doing the reverse of its sign. Instead of adding p across, you're going to move p to the left. So you're subtracting p to every single x coordinate. So that's why if you're at 6 and you're minusing p, you're going to be at 6 minus p. If you're at 3 over here, you're going to minus 3 by p, so you'll be at 3 minus p. Again, if you had the origin, you can go from 0 to 0 minus p, or just minus p. Now, that's what you have to do so far. Now, to sketch it accurately, this is why you have this interval for p. Because if you imagine it this way, suppose p was 3, even though it can't be, this means that 6 minus p will be 3, so it will be over here. But 3 minus 3 will be 0, so it will be at the origin. But it's not going to be, it's going to be less than 3, so it will be just between the origin and between where it used to be. So that's why you don't cut it through. You have to make sure just in front of the y-axis. And that's really it. You do not need to calculate the y-axis. So I was actually calculating it earlier, and I realized that this is actually a quadratic with x coordinates is 6 and 0. So it looks a bit like that. Expanding it, you get the same result. But again, you don't need to find y, so ignore this step. Just calculate it, just find the x coordinates, label it correctly, draw the right shape, and boom. That's easy 4 marks.